Expected value. Expected value attempts to answer the following question. Given an experiment, in the long run, what is the expected result or outcome of repeated trials? This is the form for the formula for expected value of an event. Each of these x's is an event, is an outcome, and each of these p's is the probability associated with that particular outcome. To find the expected value, we first need a probability distribution graph or table. A graph would be a circle graph. Notice how the percentages, the probabilities are distributed. It could be a circle graph, a pie graph. We're going to go ahead and use a table, a probability distribution table. The x would be the event, and the p of x would be the probability for each event. Note that the sum of the probabilities must be 1, or in percent, 100%. If the sum is not 1, or in percent, 100%, something's wrong. Recall that probabilities cannot go below 0 or above 1, or in other words, probabilities cannot be below 0% or greater than 100%. Histograms are very good to describe probability distributions. These would be the events. In this case, we have 3 events, and each event has its probability. The probability is read off the vertical axis. So this event, whatever it happens to be, has a chance, a probability of p sub 1. Event x sub 2 has a probability of p sub 3, whatever its probability is, and so on. A real estate developer has 2 potential projects. With project 1, there's a 30% chance of earning 1.25 million in profits and a 70% chance of earning 1.10 million in profits. With project 2, there is a 25% chance of earning 1.45 million in profits and 75% chance of earning 1.05 million in profits. The question would be, which one will produce the greater profit, project 1 or project 2? So, based strictly on expected value, which job should be developed? Well, the one that produces a greater profit. So we draw a table for each project. This is a probability distribution for project 1, probability distribution for project 2. Notice profit of $1.10 million, the probability of that is 0.7 or 70%. So these are the events, the outcomes, and these are their related probabilities. So outcome, and its probability, and its probability. Same here. These are the probabilities for these outcomes. So you run it through your formula, expected value formula. Notice it's event, probability, event, probability. You multiply, add, and for project 1, we have an expected value of $1.145 million. For project 2, we have $1.15 million. So which is the more profitable project? Well, project 2. You might think, well, this one can be rounded to 1.15. Yes, but you would have to round it to get there. This one's there already, so this one's the better deal. Project 2.